This is the lesson for Tuesday, April 7th. It's number 56. Let's fill in these boxes at the top first. The properties of exponents here. This is where we have x to a power times x to a power. We want to always remember that in that situation you add the exponents. Power raised to a power is where you multiply the exponents. This is our little difference of squares pattern, it's called, because when you multiply these out, when you have the same two things times the same two things, and one says subtract and the other says add, you get the square of the first thing minus the square of the second thing, the difference of the squares of the items in the parentheses. Notice the order too, because with subtraction, order matters. So whatever's first here, you want first there also, or the square of it. When you do a plus b times a plus b, which is what this means, you would write this out 2 times and multiply it out. You would always get the square of the first thing, and then the middle term is always going to be the one thing times the other doubled. So we write 2 times a times b, and the last term is just the square of the second thing. The only difference here is since you have minus in the middle, like we did the other day, if you write out a minus b times a minus b and multiply and simplify, you get the square of the first thing. In the middle, we get minus 2 times the first thing times the second. Minus b times minus b will still be a plus b squared at the end. Okay? Now, most of page 1 is review stuff. I thought I'd start review right here, or sneak some in, I guess you could say. So we've got a bit of information here about buying overpriced items at the zoo. I shouldn't say that, but I'm a bad person. Pack of gum for $2, $5 for a candy bar. Wow, indeed. So we bought several packs of gum and candy bars and a total of $31. So I'm going to say A will be the number of packs of gum, and B will be the number of candy bars. So what actually happened, what it says in this first sentence is, we bought some gum, and we don't know how many packs, but they were $2 a piece. So $2 times A would be the cost of all the gum we bought. Candy bars were $5. So $5 times B candy bars would be the cost of all the candy bars. Add those two together, you get the total bill of $31. Now, this is kind of like that basketball problem from a while back. If we bought as many packs of gum as we had candy bars and vice versa, then the bill would have been $46. So in other words, the number of packs of gum now becomes the number of candy bars purchased, so we changed the cost to $5 a piece. The number of packs of gum is now the number of candy bars, so that expense is $5 per candy bar. And the number of packs of gum is now what the number of candy bars used to be, so we take that old number and multiply it by $2, and that changes the total bill, story says, to $46. So it's the same idea like with the 2-point and 3-point goals with the basketball. You just switch the multipliers around, and then you just solve the system, and we can well, let's see, what does it say at the end? How much gum did we really buy? So we really want to know what A is first. We can find B, that's fine, but we really need to answer the question to know the number of packs of gum, the value of A. So that means it makes more sense to work on eliminating the B column. So let's get a 10 and a negative 10 going in the B column. To get a 10 here, I'm going to multiply by 2. To get a negative 10 here, I'm going to multiply by negative 5. I might even use a calculator today. So 2 times everything in this top equation, you get 4a plus 10b equals 62. No calculator so far. Negative 5 times everything in this equation, we get negative 25a, negative 10b. See, there's the opposites. That's the whole idea of the multiplication. And negative 5 times 46, that's negative 230. Now when we add the columns, let me zoom in just a little. 4 and negative 25, that's negative 21a. The b's cancel as we had planned. And then the negative 230 plus 62, I'm not going to chance doing it in my head, negative 168. Which means a is this number divided by this number. A is negative 168 divided by negative 21. I take the negative 168 divided by negative 21, and I get 8. 8 packs of overpriced gum. Okay? And if you wanted the number of candy bars, you could take the 8 for A and plug it in here or here and then solve for B. Here's an upstream, downstream, or with the wind, against the wind system of equations problem. Rate times time equals distance. Here's the distance. Here's the time. And what's the rate? Well, in the direction of the wind, that's where we say R plus W, where R is the speed in still air and W is the speed of the wind. So 4 hours with the wind, we covered a distance of 2420. In the opposite direction, which would be against the wind, there's the distance, there's the time. 5 hours times R minus W miles per hour. We're at 2,975 miles. So we can simplify this. We could remove the parentheses and all that, blah, blah, blah. Or it's a lot easier if you just divide both sides by 4. Divide this side by 4. You just get R plus W. And the other side, 2420. 2420 divided by 4 is 605. Divide both sides of this by 5 to get this to just say R minus W. And 2975 divided by 5 is 595. Very nice. Now we'll add, and if you add here and get R, oh, no. It's 1R, and 1R is 2R. 1W and minus 1W, they're gone. They cancel. And 605 plus 595 is 1200. So divide by 2, and we get R is 600. So that's the speeds plane in still air. Plane in still air, no wind, 600 miles per hour. And if we were asked the speed of the wind, look, if 600 plus W is 605, the wind was 5 miles per hour. Just if you're curious, wind 5 miles per hour. Just as a little by the way. And here's the last group of old things. We want to graph this equation. Guarantee you, promise you, this question or one like it will be on your midterm 3 and your final. Okay, so here's the axis, the x-axis, here's the y-axis. It's in slope-intercept form. Start at the y-intercept plus 2. and then obey the slope as travel instructions to get a few more points. It's a negative slope, which means the line goes downhill, and the rise over run 1 over 3, that means we go down 1 and sideways 3, down 1 over 3, or up 1 and to the left 3. There's the graph of y equals negative 1/3 x plus 2. This one has a y-intercept at negative 5, 1, 2, 3, 4, 5, and a slope of positive 4/3. That means we're going uphill. 1, 2, 3, 4, 1, 2, 3. 2, 4, and 3. And we're out of room. Well, yeah, we're out of room the other direction too. But this is sufficient. There's that graph. And now we're over here, and it says y is greater than all this. So for a moment, we pretend there's an equal sign there and get some points. Y-intercept is 3, positive 3. Slope is negative 4. That means we go down 4 boxes and over 1. It's a steep downhill line, or up 4 and to the left 1. Now, since it says strictly greater than, we don't make a solid line. We make a dashed line or a dotted line like that. And when it's in y-intercept form, if it says y greater than, you shade above. I know it's very slanted, but this is below, this is above. So we shade up here. All the points in this shaded area have an x and y value, so that if you would plug them in, this would be true. The y value would be more than negative 4 times the x value plus 3. Complicated to say, but all those points would in an infinity of points there for which this is true. The dotted line signifies that the points that are right on that line don't work. That would make the y equal to this, and we don't want that. We want at least a little bit larger than. And finally this, since it's in this form, if we plug in 0 for x and solve for y, we get y equals 1. That's the y-intercept. And if we plug in 0 for y and solve for x, we get x equals 5. There's our x-intercept. It says could be equal to, and notice the slope here, it's up 1 over 5, up 1. If I do that again, I get a more accurately drawn line. It says could be equal to, so we make this a solid line. Now, do I shade above or below? I don't know yet. Don't assume because of this being pointed this way that you shade below. It may turn out that way, but what you really want to do is plug in a point that's not on the line, and the most convenient and almost always usable is 0, 0. And if you plug in 0, 0, it's going to say 0 plus 0 is less than or equal to 5. Is this true? This is 0 less than 5. That is certainly true. And that means where that true point is, that's where we place our shading. So it turned out it was below that, but it won't always have that nice coincidence. Okay? Oh, that's the end of all the review stuff. And here's the only really new thing for today, is we're going to be looking at geometric figures and asked to write an expression for something, perimeter, area, what have you, using the labeling given. So if we want an area expression for a circle with radius 5x minus 2, here's a picture to go with it. What do we typically do to get the area of a circle? Pi r squared. So in this case, we don't have a number for r, we have this little expression. So this is all you really have to do. Pi times 5x minus 2 squared. Now if you really want to go to town here, you could say, well, this is pi times 5x minus 2 times 5x minus 2. And if you multiply this out, if you multiply that whole mess out, you're going to get 25x squared minus 10x minus 10x minus 20x in the middle, plus 4 at the end. And then if you really, really want to, you could use your distributive property and multiply all three terms by pi. But actually back here, this is probably quite far enough. Okay, that's 15 minutes on page 1, so I'm going to stop the camera, come back for page 2.